Welcome! We are going to kick off our Algebra 1 guided notes with little bits of review of our pre-algebra skills. So I have a little investigation for you to start. So I want to know, what do you think of when you hear the words below? You can write or draw or give an example in each box what you think of when you hear the word evaluate and what you would think of when you hear the word simplify. All right, so for evaluating, you might have said something like find the value of something. You might have also, for simplify, say something like make it, geez, make it smaller or something like that. So answers are going to vary here. All right, you might have drawn a picture or something like that. All right, so we got a couple definitions here. So an expression, if I ask you, what is an expression? And an expression is a combination of variables, constants, like numbers, operations, and grouping symbols. We evaluate expressions by finding the value. And usually we have to do, or we may have to do some sort of substitution. And we simplify expressions by combining like terms to reduce in complexity. Alrighty. So let's talk about the order in which these things happen. There is an order of operations here. So I use G as the first letter instead of P, which might be throwing you off here. When I say GEMDOS instead of PEMDAS, but G stands for grouping symbols. And I prefer this term over parentheses because it's more inclusive, right? It could be parentheses, but it could be brackets as well. E for exponents. And then in the same step, we simplify or take care of any multiplication and division. And we move from left to right. And then addition and subtraction. Also on the same line, we'll also move from left to right. Read through expressions like we would read a sentence in English. All right, so let's start with some examples here. So first, I'm asking you to evaluate this expression. That just means I'm going to carry out the operations and find the value of what's going on here. So first I look for any grouping symbols or exponents, and I don't see any. So then I notice that there's this multiplication that's happening. So we're going to multiply. And so we'll get 3 plus 10. Well, now we have addition going on here. So we will add those two together to get 13. Stepping up the complexity a little bit, let's look at example 2. Here we have this exponent, so we're going to deal with that first. We are going to square 4, and so now we have 16. So we have 16 minus 6 divided by 2. Well, according to that order of operations, we are now going to take care of this division. And so we'll have 16 minus 6 divided by 2 is 3. Now we'll carry out that subtraction. And it ends up being a happy accident that we end up with 13 again. There's that an unlucky accident. All right. So let's go ahead and flip to the back. This is one more type of evaluation that you might see, and this is where we have to make a substitution. So I'm asking you to evaluate this expression for when x is equal to 3. So what that means is I'm going to take 3 and put it into the expression where x used to be. So this is called substitution again. You'll notice that I'm leaving myself little notes on the right-hand side. I like to do that so that when I come back and look at my notes, which is why we're taking notes, right, so that we can look at them later, I remember what's going on in each step, and I'm not just looking at notes like, it made sense when we were going over it, but now I have no idea what's going on, because we've all been there, so I like to leave these helpful notes to myself. All right, so we plugged 3 in. Now I'm going to, according to order of operations, carry out this multiplication first. We're going to multiply. And we'll have 6 minus 1. And then we'll carry out that subtraction and end up with 5. All right. Now, when we are simplifying expressions, so again, that combination of variables and constants and stuff, when I asked you to simplify those, something we're often going to have to do is combine like terms. It's a common term, pun intended, that you'll hear. And when I say like terms, what I mean is that they have the exact same variable and exponent. So x's can only be combined with x's, y squareds can only be compared or combined with y squareds. Try to write and twice. That's what I get for talking and writing at the same time. All right. So let's look at what's going on here. Here we have 2x plus 3x minus 5x. So what I'm going to do is notice how these all have an x, right? So they all can be combined together, and I can just do the combining from left to right. I'm going to start with the first two. That way I'm not trying to do too many steps all at once. So if I have 2 x's and my husband has 3 x's and we pool our resources together, we have 5 x's. And then over here, we still have this minus 5 left. So what we're going to do is now, if I have 5x's, you come in and you take 5x's away from me, how many do I have left? Well, I have none. And all we did right there was combine our like terms, in both steps. All right, something we also might see when we are simplifying is having to use the distributive property. So notice that I have 3 outside the parentheses. That means 3 is gonna get multiplied by both of the terms in this expression here in the parentheses. So I'm going to start by distributing. And this is the distributive property that we are using, one of my absolute favorites in the world. So this is going to look like 3 times x plus 3 times 2 minus 1. I'm going to go ahead and just simplify that by multiplying those out. So this is going to be 3x plus 6 minus 1. And now we have 6 minus 1, which I can subtract because those are, again, alike, right? Neither of them have a variable. And so we'll end up with 3x plus 5. All right, so go ahead and try the following problems out. So I have 3 where we're kind of evaluating expressions, 3 where we are simplifying expressions. And so go ahead and check those out. Do the best that you can for me. Pause the video, actually pause it, and then we'll be able to go over those together. Okie dokie. So let's go over this first one. Here, we need to take care of what's going on in our grouping symbols first. So I'll have 10 is being divided by 5. I'm adding those together, and we have plus 1. Now, according to order of operations, we need to carry out that division there. So we'll have 10 divided by 5, which is 2, plus 1. Now we'll need to add those together, and we'll get 3. All right, so again, revisiting what we did, we took care of the grouping symbols. Then we took care of the division. And then we added. All right, next, there's a couple of ways that we can approach this. Technically, it might be your first instinct to kind of like distribute that 5, but we can, since there's no variables in here, we can actually carry out that subtraction within the grouping symbols first. So this will look like 5 times 2 plus 7. Now I need to multiply 5 times 2, so we'll get 10 plus 7. And then the last step in the order of operations is that we'll add those together to get 17. All right, thinking about PEMDAS again, right? Grouping symbols, exponents, multiplication, division, addition, and subtraction. We're going to take care of this exponent first. So I'll have 4 plus 6 divided by 3 minus 1. I'm going to divide, so I'll have 4 plus 6 divided by 3 is 2. minus 1. And now we go through left to right to do the addition and subtraction in order. So first I'll do 4 plus 2, which will give me 6 minus 1, which is 5. All right, so there's all of the evaluating. Let's go over the simplifying ones here. Okay, so I have negative 2 times 4 times minus x. I'm going to distribute that in. So I'll end up with negative 8 plus 2x, right? Because that negative times another negative was going to be positive. And then we still have this plus 2. Don't forget about it. All right, so now 2x doesn't have anything like him, but negative 8 and 2 are like terms. So we like our variables to come first. So I'll have 2x, and then negative 8 plus 2 is negative 6. Over here, we have 2 sets of distributing going on. Woo woo. All right, so this will be 2x minus 6 plus 5x minus 10. Now, in terms of our like terms, right, 2x and 5x are alike, and minus 6 and minus 10 are alike. So I'll end up with 7x minus 16. And one last problem. We're going to do 4 times 2x, 4 times 1, minus 3, making sure that negative also gets distributed. This will be 8x plus 4 minus 9x plus 6. It's okay if you need to write in that intervening step. So here, let's actually demonstrate that. So if you need to say, hey, oops, I need to show 4 getting multiplied by 2x plus 4 getting multiplied by 1, minus 3 getting multiplied by 3x, and minus 3 getting multiplied by negative 2. That's a-okay, right? All right, so there's no awards for speed. So we have 8x minus 9x. Those are like terms. They both have an x to the first power. And 4 and 6, those are like terms. So when we add those together, we are going to get negative x plus 10. And that's it, folks. Now we have kind of got the rest out of the way. We are ready to be solving some equations.